With work and power defined, we're ready to talk about energy. Energy is the ability to do work. That is, it's the ability to move an object by exerting a force. Now, with this idea of energy, another way to define work would be the process of using energy in order to move an object. So if I am exerting energy to move a book from the bottom shelf to the top shelf, as we used in a previous example, then that is work, the exertion of energy. Now, there are lots of different types of energy. We'll look at a handful of types, but first of all, in this chapter, we're going to address primarily potential energy and kinetic energy. Potential energy is the energy due to position. In other words, it's energy relative to some other point. And then you have kinetic, the energy of motion. First of all, potential energy is, again, the energy associated with position. There are different types of potential energy. One of the primary ones we use is gravitational potential energy. In other words, it is the potential energy, the energy of an object that has the potential to move due to the forces of gravity. So how far can an object move? Well, that depends on the height h of an object. So if you have a book that is near the top of a building, it is some height h relative to some other height. So in this case, we are measuring the height h relative to the bottom of that floor, so just to the floor of that level of the building. And so it has the potential to fall from the height that the book is down to the floor of that level. Now, if you move the book outside, that would change. You would have potential the book could fall all the way down to the surface, so your height h would be different. So your potential energy always depends on some reference height. Now, let's go back to this idea that this level here is our reference height. What if the book were to fall all the way down to the ground, but we kept this as our reference height? Well, in that case, our potential energy would become negative because we are now below the reference height. Now, this equation here that I've highlighted here, that is the basic equation for calculating potential energy. Remember, work is force times distance. Well, the force that we're dealing with is gravity. So the force of gravity would be mass times gravity, and the distance that the book could fall is the height h. And that is where this comes from. Now that's gravitational potential energy. There are lots of other types of potential energy. You have elastic potential energy, which is the type of energy due to springs. You also have electric potential energy due to the separation of electric charges. There's another word that is related to electric potential energy, and that is voltage. Again, we will address that when we talk about electricity. Now, the cool thing about potential energy is that work can change potential energy into kinetic energy and back again. For instance, let's say instead of a book, we have a ball. You drop it from the window outside of the top floor of a building. It's got potential energy because it is some height h from the ground. Well then, drop that ball, it will start moving to the ground. It is moving, so it is now kinetic energy. It's lost its potential energy into the form of kinetic energy. And then the ball will bounce and come back and then stop at some height, probably pretty close to the height where you dropped it from. So in this case, you started off from kinetic energy at the ground where it's moving to the top where it stops moving, and you are now in the form of potential energy. So we've gone from potential energy to kinetic back to potential. That's what work can do, is change the energy from one form to another. Okay, let's talk a bit about kinetic energy now. Kinetic energy is the energy associated with motion. And so kinetic energy results from work or change in potential energy. That's where kinetic energy comes from, as we just described. The way we calculate kinetic energy is 1/2 of the mass times the speed squared. Now, notice that since speed is squared, that's going to affect the proportionality between kinetic energy and velocity. It's no longer directly proportional, it is now a squared proportion. In other words, if you double the speed, in other words, increase the speed by a factor of 2, then you have to square that factor. Your kinetic energy increases by a factor of 4, that is 2 squared. Now, energy can do work in many, many different ways. Energy can do work against inertia. In other words, you have an object at rest. Energy can do work to start an object from rest to a moving inertia. It can do work against gravity, as we saw in the case of potential energy. It can do work against friction. It can do work against shape, or any combination of the above. So here's an example of doing work against inertia, moving an object forward. Inertia is wanting the object to stay where it is, but the work energy moves it forward. Against gravity, lifting an object from the ground. Against friction, sliding an object across the floor. Shape, say compressing a spring. Or again, any combination of any of those. So energy can do any of those types of work. Here's some other types of energy. We have mechanical energy, which is what we've talked about, kinetic plus potential energy, the combination of those two. You also have electrical energy. You have chemical energy, which involves chemical reactions. You have radiant energy. Another way to talk about that is what we call electromagnetic energy or radiation. One example of radiant energy would be visible light. That is a very small part of the full electromagnetic spectrum. One other type of energy is nuclear energy, the energy involving the nucleus of an atom and reactions involving those nuclei. Now, when you have energy, it can always be transformed from one form of energy to another. It can always be converted from one form to another. We saw this with the ball outside of the window of a building. You can also see that with a pendulum. When you have a pendulum at its maximum height, you are completely in potential energy. As the pendulum falls, that energy is slowly converted from potential energy to kinetic. When the pendulum is at the bottom, you have converted your energy completely from potential to kinetic. Energy flowing from one form to another is a very natural process. Another great example of that being a natural process is sitting on a beach. You have sunlight. Well, the sun itself is one big nuclear reaction, so you have nuclear energy. And that is converted from nuclear energy to visible light or radiant energy. And then it goes from radiant energy all the way from the sun to you sitting on the beach, where you absorb it and it becomes heat. So energy is being converted all the time from one form to another. And that leads us to a very important principle, which is called conservation of energy. And basically, the conservation of energy means that energy is never created or destroyed, but it can be converted from one form to another. It's important to realize that the total energy always remains constant. If we were to add up all the energy of the entire universe, that number would never change. So here are some examples of how energy can change, just figures in your textbook. You can always go undergo change of energy from, say, chemical to radiant energy. Going from chemical to radiant would be what we call oxidation. Radiant energy back to chemical, that's the process known as photosynthesis. You could also go from chemical to electrical, which would be, say, a battery. But if you go from electrical to chemical, that's called electrolysis. That would be, say, the process of recharging a battery. Radiant energy to electrical would be, say, a solar panel. Going from electrical to radiant energy, that would be a light bulb. And you can see the process. These are the different types and examples of energy conversion from one form to another. What's important is that in each and every one of these examples, the energy is never lost. Energy is never created or destroyed. It's only converted from one type to another.